Looks like I left my stream on last night. Oops. But I'm gonna be trying to get some C++ into blueprints here. Right now I'm just running through a...
Space? Okay, and...
I think I'm also gonna use coworker some. So, I mean, I really should just copy this shit right over. Boom. Boom. Continue the start I'm gonna show you guys the conversation that I'm having right now. We're having a design conversation with our coworker, ChatGPT. I was gonna tell it that we don't need to normalize the. That will happen externally. There. Yeah. Show me implementation with yeah, sorta. Right now I'm having an AI write me an octree. Nice. I'm planning on using it as a procedural generation tool rather than a spatial division tool. I mean, it's still a spatial division tool, but it's more like to represent a universal scale. I can figure out the leaf node the player's in and the chain to the root. And then when I want to generate my stars, I can go like 10 up and then generate, well, probably more than that. Go like 15 up and then generate like a point cloud, and then I can transpose a point cloud to a specific depth in the octree, let's say 10, and then that becomes my local stars, and then you can crawl up another 10 levels and do the same thing for like other stuff. Yeah, this is more like I'm trying to use it to generate a data structure rather than using it to like render things to speed up proc gen in a really large system, so that like I can only kind of proc gen the stuff around the player that matters, or like within distance. Like you could see a star from not as far away as you could see a galaxy. You know what I'm saying? So yeah, I am right now. I'm just working on a custom octree implementation here. Come back to that. So like the idea here would be like I want to procedurally generate some stuff, and so like imagine an octree with like an arbitrary depth, but it's completely sparsely populated. So let's say it's 100, like its max depth is 100, which is like makes it so that if 1 meter was a leaf node, then it would be bigger than the universe. So but when nothing's in it, all you have is the root node. So let's say you want a player to be able to like traverse through that, and you want to have like runtime procedurally generate stuff the user might be able to see. Smaller, so like you could think of it like it's dividing space every level you go down, right, by half. So if your bottom node is 1 meter and you have 100, then your total size is 2 to the 100th power meters. So what you can do then is, instead of trying to generate an entire universe from the root node down, you can generate one random path to the bottom and put the player there, right? So you're going to say at every point in this path that matters, we're going to generate the procedural content. So like you're going to be in a planet system with a star. like at the bottom levels of the tree. You're going to be in a stellar cluster at the middle levels. You're going to be in a galaxy at the higher levels. And what you can do is, now that you have that path to where you're going to spawn the player, at the very, like, maybe, let's say 5 levels up, you can spawn you go up then down. So let's say you want your planets and your star for the local system at level 5 of your data octree, like your conceptual octree. Then you could go up to like level 7, and then you could say generate me a single point at level 6, and that'll be my star, and then generate me 1 to 10 random points at level 5, and that'll be my planets. And like now that you know that you're generating stars at level 7 and planets at level 5, you can store that, and you can be like, okay, so now when I see stars, those are level 7 of my 100 depth octree, and my planets are at level 5. And then you can say, but I want this to be part of like a stellar cluster, and that's much bigger than a single star system. So we're going to go up another 10 levels from where we generated stars to level 17, and then we're going to go up 3 levels past that. And at 3 levels past that, we're going to say, okay, you generate a cloud of points, and then decompose it into nodes 3 levels down. You see what I'm saying? So like if you can think of an octree like, and like this stuff like hurts my head just trying to like think about it, but like if I go into GIMP, right, I can draw it maybe. So like you can and like actually explaining this stuff helps me hash it out in my mind as well, so this isn't even a waste of time because a lot of today is just conceptualizing how I want to do the proc gen. But like let's say you want to generate a player at the very bottom of the tree and it's 100 depth. Well, you can just generate a random string of 0 to 7, like a random int array, 100 long, of 0 to 7 in each place of that. And then when you get to the very bottom, you can spawn your player. And your player's here at the bottom of the octree, and there's a bunch of branches going all the way up 100 places until you hit the root way up here, right? So I like obviously if I populated every single node in a root in an octree that deep, there's not enough memory. Like you would run out of hard drives. I think it was like multiple petabytes to do that. So you can't do that. But what you can do is you can say, oh, I only want to see the procedural part of this universe because I can't define the whole thing, but I can numerically define whatever region like I'm focused on relative to the player. So I think about like what does the player see? Okay, well up close, the closest thing they would probably see would be a planet, and then after that probably like a star or maybe like some asteroids. Or like fog, things like that, right? So I can say, well, if this is a meter, if my bottom's a meter, how many levels do I gotta go up the octree until one octree cube is roughly the size of a planet? And it's probably like 12 or 13, right? And you say, okay, I want to generate some planets at level 13 in my octree, but you can't just go to level 13 and spam the whole depth, like that whole layer depth, because it's like at level 13 that layer depth spans the entire octree, so we can't just generate paths randomly in this range because that's huge, and most of these stars would never be visible by the player. But what we can do is we can say, okay, so what kind of volume will my planets be contained in? And we can say, okay, well, how big is a solar system? All right, so a solar system is this big. So like our solar system size is like right here. So what we can do is we can go up to right here, and we can say, okay, from this point in the tree, I want you to populate this level of your children with a point cloud that I randomly spawned in your space, right? So I spawn a point cloud of 8 points for 8 planets, and you can provide a function to determine like the XYZ layout of how that stuff's going to spawn as well, so that you could actually lay them out in elliptical patterns or things like that. And so now you have this point cloud at this level, and you want to decompose this point cloud into nodes at your planet level. And then inside this node, we can store like an object that contains a bunch of randomization parameters, and that's how we can decide like our actual planet size relative to its containing bounding box and such. And that ends up happening, if you're like in your mind's eye thinking about a top-down like binary tree, is instead of trying to populate this whole depth with stars, we just populate like a cone of this depth that would be in range of our current let's say stellar cluster, like, or this is a solar system, and then like up here we could say, oh, and this is a stellar cluster, right? And what you end up doing is you only populate the nodes that are in the children of the layer you're at, so you can constrain your Procyon coordinate space to where you're not trying to generate an entire like universe worth of shit. You're only trying to generate at each level the things that the user would potentially be visible to the user. So like a star is visible from further away than a planet, so you generate those from higher up in the octree. A stellar cluster is visible from further away and so what you can end up doing is like I can just say, okay, well, here I want to generate galaxies, but only this slice right here of the tree. And then I'm going to pick the galaxy I'm actually in. I don't need to generate anything for below these galaxies, because at this level I'm only going to see the galaxy. So I don't need to know what's inside these. But I do need to know what's inside the galaxy that's along the path that the player's actually on, right? Because that's the galaxy they're in. And so when I'm on that path, I could then go down some more and I could say, okay, they're in a cluster here, and that cluster is going to generate stars here. And so I just generate this cone of stars, and then finally I could say, but I don't care, I don't need to generate the star systems for any of these stars except for the one that my player's on. And the one that my player's on, I need to go ahead and do another slice going down, and we're going to generate our solar system and like our local solar system. That's my idea anyway. And so hopefully that would allow you to, like, instead of having to calculate, you know, quadrillions of stars to fill up the whole tree, you can just go up a certain level, like, oh, I'm at this cube level and I'm going to define this as like a stellar quadrant or something, and then instead of having to like exhaustively travel these, I can just generate like a 10,000 point cloud, put it in, like based on a distribution function, put it in this and say, okay, now I want you to decompose your octree down to star sized. And then you basically have your visible stars represented in your octree as data. And like the reason I don't want it dividing up like into actual space is because you have to do tricks with the space is too big to functionally represent in the game. So you have to do tricks to get things to scroll like different. Like basically you would apply a modifier to the movement of everything depending on how far up the octree it is, and the further up it is, the slow. Like imagine yourself on a treadmill, and things that are closer to you you get closer to them faster, and things that are further away, like that kind of thing. And that's it. That's what I'm trying to figure out. I gotta let my puppy out there. Yeah. All right. Hey, babe. Got incoming peppers. So I'm trying to leverage my understanding of how the algorithm works and my lack of understanding of how C++ works to use AI to write this thing, basically. What is And then what you can do is you can basically say, once you determine the sizes, like you can calculate roughly how, like what layers you should generate stuff on, and once you come up with that, you can just create a table that's like, at depth 7 we generate planets, at depth 9 we generate stars, at depth 13 we generate solar systems, at depth, like that kind of shit, right? The F vector. I'm assuming it's just add. Yeah, I thought so. So it makes a couple mistakes. This is wrong though. I help you block out the code really fast, but it gets shit wrong too. Let's see if we can tell it to update its code. Yeah, we can't use that. Everything has to be relative in this octree. So like the difference between this and like one is it's like a conceptual space rather than a real space. So like everything, it's so big, we can't do anything like get all nodes at depth, because if you have an octree that's order 100 and you say get all nodes at depth 100, your computer will catch on fire and die for sure. Like you will run out of memory, you will run out of processing power. Like it's too much. So you like that's why we like you travel up the tree, and then you spawn at a higher order. You spawn things that you want at a lower order, and then you decompose that point cloud into the lower order. And that's how you can constrain, like, because you may want to be able to see like from far away. You may want to see like a galaxy, right, from really far away. You may want to be able to see that much further than a star, but you don't need to be able to see the individual stars in that galaxy at all. And likewise, from a distance further than a star, you could see a star cluster. But from those same distances, you don't need to see every star. And it's like that all the way down the chain. It just hurts my brain trying to think about it and implement it. And it's also I'm not an expert in C++ by any stretch. I'm a complete noob. I'm a expert in a lot of different programming languages, but this is not one of them. Okay, so Okay, let's start from scratch. Okay. Leaf nodes. Let's start it from scratch again. The method of insertion into this tree will be providing a point cloud to a given node in the tree. Given node in the tree, as well as a depth which decompose to will then another will take a node as a normalized f vector point cloud array as well a node normalized f vector point array was depth from the node which at the point set will then scale out and then points into child nodes let's see if we can do it. It's a way that we can basically represent a much larger conceptual space than we're capable of drawing in a game editor. I have this is like my real project, and then I have the other one where I was working on like skybox generators and stuff like that, which is fun, but this is the real interesting shit. Octree, enter the octree. All right, let's see how this stacks up. I didn't write any of this, so I don't feel bad about deleting it. chain, children, bounds, you insert okay, now for our get method we will provide a octree node and a depth, and it will return the populated child nodes at that depth from that node. Once it reaches a leaf node or node of desired depth. Wait, was this sparsely populated? That's important. This will sparsely populated. We should not add leaf nodes. Only populated nodes from the given node at depth. Like, I know how to describe what it's supposed to do, but I don't know how to code it in this. So reaches nodes, that's the list nodes.
Hey, Sam.
Hey, what's up?